Hi, it's Mr. Polochak here in another Long Island forest to talk to you about how a molecule shape determines its biological function. And what better example than to talk about pheromones. Somewhere around in this forest there are Long Island white-tailed deer. And because it's the fall season, any day now, the female deer are going to start to release a pheromone. A pheromone is a chemical that is emitted by the deer to tell the male deer in the area that she is reproductively ready. And that pheromone has a very specific shape. So as they emit that pheromone, the males have receptors that pick it up. So for example, this might be a pheromone, a chemical release from the female. You can see that the molecules that make up this molecule have a specific shape. And maybe this site here activates a receptor in the males, and it triggers a response in their bodies to let them know it's the time of season to make a baby. And they will track those females and they will mate. So this is one great example of how molecular structure determines biological function. Now, the use of pheromones for other reasons than attracting a mate could be for population control. We've used baits with pheromones to attract certain insects so that we can figure out their population. And these insects can behave as pests. So we can put them in baits to lure them in and trap them, maybe survey their numbers, or even just to kill them because they're pests. For the deer, the Long Island deer, it's fall season, so hunting season has begun, and hunters can actually use pheromones that attract the male deer, and they use that in the hunting season so that they can get the males. Those are the ones with the antlers. So these are some examples of ways in which pheromones are used in nature. Now what we're going to do, the best way I can show you this in lab, is to show you the effect of pheromones on termite behavior. So what we'll do is we're going to look at how termites respond to the presence of a pheromone, and how they will track, thinking that the pheromone will lead to the opposite sex. What we're going to do is take a termite and we're going to put it on the paper, and we will find that a black Bic pen will match the pheromone of a termite. So we can do an experiment with a black Bic pen, a blue Bic pen, a red Bic pen. We could use a pencil or even a Sharpie and make trails on that paper to see what the termite will follow. So in the next little video clip, you're going to see that experiment. I'm not going to show you the results. I'll just show you the effect that the black Bic pen matches the pheromone. And what does that mean? It means that the black Bic pen ink matches chemically the pheromone released by a termite. So where you might see this red here and this structure here, maybe that's the real pheromone from a termite, but the black Bic pen might look like that. So this part still works. And these animals have receptors, so that when the pheromone hits that receptor, it triggers a response, which is the behavior, whether you're a white-tailed deer or a termite. So let's take a look at that video clip. I'll show you the effect of the black Bic pen on termite behavior, and then you can go ahead and do an experiment to see how the other writing instruments might affect that behavior. Does it have the same response or no response at all? All right, so let's go check that video right now. Okay, so here's the termite walking around on the paper, okay, and there's no ink there, so he's just randomly walking. Now I have my black Bic pen, okay, and where'd he go? There he is. Just hold on, we're gonna reset this. Okay, so here you can see one of the termites, and there's no ink on the paper. He's just walking all around randomly. He's not sure where he is. He's been disturbed from the forest. And here's my black Bic pen, and let's see if he'll follow it. I'm gonna make a trail. I'll make the trail over here, and let's see if he follows the trail. So for some reason, the ink of a black Bic pen mimics the pheromones emitted by termites. And you can see he kind of goes back and forth, but ultimately he is following that pen line. Look at that. Now, that means the molecules that make up the ink of the black Bic pen match the molecules in shape as the termite pheromone. So the shape of a molecule determines its function. See, what will he do now? Oh, look at that. He's just going to walk up and down that track, because what does he think is at the end of the track? He thinks there's a female. And that's our lesson on pheromones. What we'll do is we'll head back to the classroom and we'll talk about how atomic structure and the formation of molecules determines the shape, and how shape ultimately determines the function of biological function. Now you can go ahead and test this further. Maybe instead of the black Bic pen, you can use a red Bic pen. You can even use a black Sharpie. You could try a pencil. Okay, whatever you like. Okay, you guys, so that's it. I hope that helped. That was a lesson on how molecular shape determines biological function. And if you'd like to see other videos, you have suggestions, feel free to make a comment. Let me know what videos you'd like to see. If you haven't subscribed, you can click here to do that. And I hope that helped. See you next time.